Hi, everybody. Um, Happy Easter. Happy Passover. I hope everyone is healthy. We're today we're going to be starting on the respiratory system, and we're going to, even though this is not going to be on exam three, I'm going to go on and put um, part of the slides up today. You can look at them if you want to put it off. I will go on and post the exam on Tuesday. So if you want to take it, don't want to think about this and take the exam on Tuesday before you do that, that's okay too. But I'm going to go on and we're going to cover the respiratory system this week. And then we have two more systems to cover by the end of the semester. So anyway, with the respiratory system, we're going to be talking about 5 processes that are involved in breathing. And I always ask in class, why do you breathe? What is the point? And people will usually say, because I'll die. Well, duh, of course. Of course you'll die. Why will you die? What is the point of all of this? It is so that you have oxygen to be the final electron acceptor in cellular respiration, the release of energy stored in chemical bonds. So how are we going to get there? We have 5 processes. I'm going to move out of the way so that you can hopefully see them. And Deb, I did move this closer, as close as I can, to the board, so hopefully you can read. So anyway, here it is. All right, so we have these 5 processes, and the very first of them is right here. It's called ventilation. Now, what is ventilation? It is the movement of atmospheric air into and out of your lungs. Now, why do we do that? We do that because the movement of blood gases into and out of your lungs is driven by diffusion. And you might remember that diffusion is the movement from an area of high concentration to an area of low concentration. So you need to change the air out because what's going on? You need oxygen, we said. So you have a high partial pressure, a high concentration of oxygen in the atmospheric air. But then as it's moving into the capillaries, that partial pressure drops, right? So you need to change out the air so that it continues moving, flowing into the oxygen depleted blood that has made its way to your lungs in the pulmonary circuit, right, of circulation. The other gas that we're concerned about here is carbon dioxide. Carbon dioxide is the waste product of that cellular respiration we were talking about. And so we have high concentrations of carbon dioxide in the venous blood and low concentrations of oxygen in the venous blood. Why? Because the oxygen has left the blood and CO2 has moved into the blood, in all cases by simple diffusion. So you're going to be needing to change out the air in your lungs to facilitate simple diffusion of oxygen into the blood and carbon dioxide out of the blood. This movement from the lungs from the atmosphere into the capillaries in the lungs, this exchange of gases is called external respiration. This is the respiration that is occurring, the movement of blood gases either into or out of the capillaries that is occurring in the lungs is called external respiration. And the whole point of it is to replenish the oxygen in the blood and to remove the excess CO2 that is now in the blood. The third step, transport, that's circulation of blood gases through the circulatory system. And then if you remember the blood vessels, we talked about how you have arteries that become arterioles, that become capillaries, capillaries. And we had said, what happens in capillaries? Capillary exchange. In capillary exchange, this is also, we had said in capillary exchange, this is where nutrients move into the tissue fluid as well as oxygen. Oxygen diffuses from the blood into the tissue fluid, and we had talked about water and nutrients diffusing in and water and waste products diffusing back into the capillaries sort of after the fact. But we're going to focus on the gases now. And so internal respiration is the movement of the blood gases, of the oxygen-rich blood that enters into the capillaries, releases its oxygen. Why? It releases it because you have a higher concentration of oxygen in the blood than you do in the tissue fluid. Simple diffusion. It's released from the hemoglobin that's carrying it, and it moves into the tissue fluid. And from there, where does it go? It goes into the cells. We have cellular respiration, the diffusion into and out of the cell, and the use of the oxygen. We had talked about, we studied cellular respiration, and we'd said it's all about releasing the energy stored in complex macromolecules. Okay, so these are the 5 steps that are important in the respiratory system.